Hi, welcome to Lesson 17, Session 1. We will be working in our Ready Classroom Math Workbook today on pages 347 through 350. We will be exploring dividing decimals. We, for the last couple of weeks, have been working on multiplying or multiplication with decimals, and now we're going to be moving into dividing with decimals and taking a larger part and then breaking it up into smaller parts. So with that, go ahead and turn to page 347 in your Ready Classroom Math Workbook, and we will get going. So we are, like I mentioned before, we are going to be explore dividing decimals. So now that you know how to multiply with decimals, you will learn how to divide with decimals. Use what you know to try and solve the problem below. Mr. Kovich is preparing materials for a craft project. He needs to cut 2 meters of string into pieces that are 2/10 of a meter long. How many 2/10 of a meter pieces can he cut from 2 meters of string? So first of all, what are we talking about? We're talking about string, okay? And we need some of this string. So the question that we're being asked is, how many 2/10 of a meter pieces can Mr. Kovich cut from 2 meters of string? And then the important information is that he has 2 meters of string, and he needs to cut those 2 meters into pieces that are 2/10 of a meter long. So to solve this problem, what is it that we're trying to do? So what we're trying to do is that we know that we have 2 meters of string. So we've got this string and it's 2 meters long. And then we're going to divide that string into smaller lengths of string that are 2/10 of a meter long. And then the resulting answer, or in this case, the quotient, remember the quotient is the answer to a division problem. So we have our dividend, which is the whole number. Our divisor is what we're dividing the dividend into. And then our quotient is our answer. So what we know that this answer here is going to tell us how many pieces of string that go into this 2 meters. Now, you may not know how to do it this way just yet, but I'm going to go ahead and show you what it would look like if we drew a picture. So if we drew a picture and we had this length of string, and this length of string from here all the way over to here is 2 meters. And then to here, that would be like 1 meter. And then if I wanted to break this up into tenths, remember that would be breaking it in half. That would be a half of a meter, or 0.5 of a meter. And then if I wanted to further break that into, let's go into tenths, then I would go something like this. All right, now I have it broken into tenths. Now I'm going to see how many times I can add 2/10 to get up to 2 meters. So if I start here at 0 and I hop over 2/10, that takes me to 2/10. 2 more tenths, 2 more tenths, 2 more tenths, 2 more tenths. And then I keep doing this all the way because each of those little tick marks is a tenth. I keep doing that all the way until I get over to 2. And now I'm going to count how many of these jumps that I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what this picture shows is that I start with 2 meters of string. I break the string up into parts that are 2/10 of a meter long. And I have, when I go through all of those sections, I have 10 2/10 of a meter sections. So my answer, what is 2 divided by 2/10? The answer is 10. Another way I can look at this division problem is I can rewrite it as a multiplication problem. So a number times 2/10 equals 2. Now we know that using our powers of 10, that if we plug 10 in there, 10 times 2/10 equals 2. Because when we multiply, we move our decimal to the right, and we're going to move it to the right one place because we have 1 0, and we move this decimal over, and then that equals 2. So the answer, how many pieces of string can we get out of 2 meters? The answer is 10 pieces of string. All right, let's go to the next page. So looking back, it says, looking back, explain how you found how many 2/10 of a meter pieces are in 2 meters of string. So what we did, in this case, we repeatedly added 2/10, maybe, if it, there we go. We repeatedly added 2/10 until we got to 2. Then we counted how many groups of 2/10 we had. So what I did on that number line was essentially repeated addition. I kept adding 2/10, 2/10, 2/10 all the way until I got up to 2. I also could have done it this way. 2/10 plus 2/10, that, and then keep adding and adding until I got up to 2 meters, and then I could have counted how many times I added those 2/10. That would have worked as well. But I just did it on a number line, but you could do it not in a number line as well. So now we're going to go ahead and look ahead. It says you can look for patterns in division to see how dividing whole numbers and dividing with decimals is alike and different. So for part A, it says complete the quotients in the table to see the patterns in division. So 2 divided by 2. That, if we said this, that's the expression. This expression in words is how many groups of 2 are in 2. So if we had 2 wholes and we divided it by 2 wholes, our quotient or our answer would be 1. Remember that any number divided by itself is 1. Now, based from the last page, we know that 2 divided by 2/10, we know that all you're doing is you're moving that decimal point one place value. So it is right here, and then you're moving it over here. Whenever you move that decimal, as long as these two numbers are the same, it's moving it a power of 10. So if it moves over one decimal, that means how many groups of 2/10 are in 2? The answer is 10. Now, and to show you that, I actually want to show you what that looks like on, I do want to show you what that looks like because it's sometimes hard to see. Okay, so let me go ahead and zoom out. So here are 2 holes. Now, I'm trying to see how many groups of 2/10 are in 2 holes. So I happen to have 2/10 here. So in 2/10, there is 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups, 7 groups, 8 groups, 9 groups, 10 groups. So when I'm dividing 2 wholes into groups of 2/10, as you can see, as I just showed you, there are a total of 10 groups of 2/10 in 2 wholes. Isn't that crazy? Yeah, I thought so. And I love this visual of looking at it with the decimal, with the hundredths cubes. All right, so now we're looking at, so if 2 divided by 2 is 1, 2 divided by 2/10 is 10, What is 2 divided by 2 hundredths? Look at the pattern. How many groups of 2 hundredths can fit in 2 holes? Now, what that means is, if I had my 2 holes, here are my 2 holes. Let me go back out. Okay, there are my 2 holes. Here are my 2 hundredths. Now, how many groups of these 2 hundredths are in these 2 holes? So I'm not going to count all the way up because I promise you it's a giant number. But if I took these 2 and I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and kept going all the way through both of these holes, I'm going to tell you that the answer is 100. There are 100 groups of 2 of these in both of these holes. So when we look back at our chart here, 2 divided by 2 hundredths is 100. Now I want you to look at the pattern. Every time we move the decimal point over one place, it goes up by a power of what? 1 times what is 10? 10 times what is 100? Every time this decimal moves over one place, it goes up by a power of, yes, hopefully you yelled 10 at home because that is the answer. It goes up by a power of 10. So now, if we're looking at just the equations, 2 divided by 2 or 2 groups of 2, the answer or the quotient is 1. 2 divided by 2 tenths. How many 2 tenths are there in 2 holes? The answer is 10. 2 divided by 2 hundredths. How many groups of 2 hundredths are in 2? 100. So looking at part C, it says, how does the quotient compare to the dividend? So how does the quotient compare to the dividend when the divisor is greater than 1? So only in this top row, if the divisor is greater than 1, if this number here is greater than 1, the quotient is going to be less than the dividend. But if the divisor is less than 1, the quotient is always going to be greater than the dividend. Let me say that again, and while you're writing it down. When the divisor is greater, that means when this number here is greater than 1, the quotient or the answer is going to be less than the number you start with. However, when the divisor in both of these two examples, when the divisor is less than 1, the quotient is going to be greater than the number you started with. I know, it's crazy. It kind of blows your mind when you think about it, but it's because you're trying to see how many of these smaller parts fit in this larger dividend. When these numbers are less than 1, you're always going to get a quotient that is greater. Super tricky. So now I want you to reflect. It says, think about 2 meters divided by 2 tenths of a meter. Why is the quotient greater than the dividend when dividing by a decimal less than 1? I want you to tell me what you think. So the quotient is greater than the dividend because, and then tell me why. Go ahead and pause the video and write what you think on the line. When you are done, we're going to go ahead and go to page 349. Now, page 349 is talking about something called an inverse operation, and I haven't really talked about that yet. But an inverse operation, well, I should take that back. We've talked about inverse operations before, just not in today's lesson. So an inverse operation, remember, inverse is a fancy way to say opposite. So we typically put together different operations to be the opposite. So, for example, Multiplication. Multiplication combines equal groups to find a total. So when you're multiplying, you have a group of 3 and you multiply it by a group of 4 to get a larger, to find out how many you have all together. So you multiply the two groups to get a total number of people or whatever it is that you're multiplying, okay? Division takes the whole number and then separates the total number into equal groups. So when 3 times 4 is 12, 4 times 3 is 12. Both of those are multiplying. Dividing gives us kind of the opposite. We start with the whole, we divide by one part to get the other part. So 12 divided by 4 equals 3, or 12 divided by 3 equals 4. So basically, an inverse operation are two operations that undo each other. So often we refer to inverse operations when we're adding or subtracting. But in this case, we're talking about the inverse operations of multiplication and division. Another example would be 5 times 8 tenths equals 4, and 4 divided by 8 tenths equals 5. Or 24 divided by 4 equals something. We may not know what it is, but do we know 4 times what equals 24? Yeah, so you may in your head not know what 24 divided by 4 is. However, you might know that 4 times 6 equals 24. Remember that you can use the inverse operation to help you figure out what it is that you're supposed to do. Another example, this is similar to the example that I drew on page 347, but we have 2 total, and then we divide it into groups of 5 tenths. So how many groups of 5 tenths do we have? We have 4 groups of 5 tenths, which equals 2 wholes. Or 2 wholes divided by 5 tenths equals 4 groups, meaning that there are 4 groups of 5 tenths. And then the final example is 6 times 2 tenths equals 1 and 2 tenths. Or 1 and 2 tenths divided by 2 tenths equals 6. So the inverse operation is just taking a multiplication sentence and rewriting it as a division sentence, or taking a division sentence and rewriting it as a multiplication sentence. You're going to go ahead and do number 2, number 3, and number 4 on your own. And then when you're finished, you will check in with your teacher. If you have any questions, as always, you can go ahead and email your teacher. Otherwise, we'll see you next time.